Everyone. So today the topic of my talk is the equipment and specifications of machineries in the grain processing sector, as introduced by Priya Madam. So basically, understand this: the grain processing machinery are majorly divided into two categories. One is cleaning machinery, and other one is grinding the machinery for getting the milled products. So I'll try to divide this into two categories for the better understanding of all the candidates present in the session today. So first thing is cleaning processes, whichever grains we are going to handle, be it rice, wheat, pulses, millets, anything, and also to produce high standards of the mill products, it is essential to thoroughly clean the grains. So whenever we talk about cleaning, the basic objectives of cleaning is removing anything which is not that particular grain. Suppose if I'm talking about rice, so anything which is not rice is definitely a impurity. So we intend to separate that. The second one comes is the damaged grains. Say if it is a wheat, so if it's a broken wheat or immature wheat or the kernel burnt, any grain which is not in its sound state is a impurity. So this should also be removed. And of course, there will be certain surface dust or maybe pesticide residues or anything insecticide and all. So that is also part of impurity. So while cleaning, that also has to be taken care of. So if I say anything which is not a sound grain is an impurity. So this should be our first objective to start the cleaning process. So we intend to remove everything which is not a sound grain. So of course, now if you see this slide here, these are the general impurities which are found. Okay. So if you see these impurities, they are not of same size, same shape, same color maybe, right? So all these impurities need to be handled using different equipment. It is not that one single equipment will take care of all the equipments here, right? So basically, if you see the process of cleaning is designed with the machineries which may use one of these or multiple of these principles when a cleaning machine is designed to do a certain job for a grain processor. So in my first half, I will try to touch on these principles and try to also get some machines which are using these particular principles and all. So the first principle is size and dimension. If you see, you can see this picture here. So this is a general size separator equipment. So any grain now, when we use to we intend to separate a particular impurity based upon size. So two things we intend actually. One thing is the impurities which are bigger in size of that particular grain, and one is which are smaller in size of that particular grain. So of course, for separating the impurities based upon size, we need a certain media. In this case, the media is sieve. So we are all aware that sieve is the one media where we use it to segregate the impurities based upon size. So this, when it comes to the different grains, wheat, rice, again the pulses and all, there can be different designs in which the sieves can be designed, right? So one thing, it can be flat, just a perforated metal sheet, just like in the size separators. It can be even cylindrical, like in machines like drum sieve and all, or maybe polygonal in the real machines and all. Right? So sieve size, sieve's shape can be anything, but ultimately the principle which it works on is size. So the screening, just the touch of the contact of grain and sieve will not help it. Right? So it needs certain motion. It should not be too fast. If it is too fast, even our accept grains will go as the overtails, and if it is too slow, we lose on the capacity. So proper synchronized motion has to be maintained when we address the impurities on the side, right? So this motion, of course, can be given by the gravity itself. You can see this picture here. The sieve deck is little bit inclined. So we take ultimate this one of the gravity itself for the motion, and of course the other way is to have the motor. The motor has been put. Okay. So these motions can be either gyratory, which are rotary, or reciprocating, which are vibratory and all. So they work on the principles according to that. So whenever we are using a motion of rotary, the separation actually happens based upon the length, right? And whenever we use the principle or the motion based upon the vibro, this and all, the separation happens based upon the width of the kernel of the grain, right? So of course, when the sieve any equipment works, it has to be maintained properly for a longer run to get the best possible efficiency out of it. To do that, suitable screen surface is important, right? And appropriate motion is important, and also the sieve cleaning mechanism. Over a period of time, what is going to happen is the material which is of the similar size of the perforation of the sieve what we are used is going to stuck in between, right? So if it happens, eventually what we are losing is the shifting surface area, right? So proper cleaning mechanism, normally in the separator which is there on the slide, there the cleaning mechanism is the rubber balls. The rubber balls will be hitting the screen during the motion itself, right? On its own, it will be keeping it clean. But of course, that will not be sufficient enough in a long run. So at every shift or maybe every day, based upon the running capacities of that particular machine, you have to clean the machine by hand also, right? But the operators which are using that needs to attend to it. So for getting the maximum output of it. Of course, the rubber balls also over a period of time they lose the elasticity and all. So one test of checking the feasibility or efficiency of that rubber balls cleaning mechanism is to take out the rubber ball and just drop it from a certain height. If it bounces back around 60 to 70% and all, that means it is working well. If not, if it is not bouncing back more than the 60-70%, it is time to replace those rubber balls and all. So this is the way normally these size separators are handled. Size separators come in capacities of as low as maybe 500 kgs per hour to as high as maybe even 40-50 tons per hour. And also based upon the capacities, size separators are used. There are also some equipment like drum sieve. Drum sieve are cylindrical screens and all. These are basically used for higher capacities. It starts from 20 tons per hour and it can go up to even 400, 500 tons per hour and all. Basically, in the ship unloading systems and all, wherein the material comes in ships and all, and it needs to be clean at the fire itself, right? So those because the time of ship unloading will be restricted to 1 day or this one, and the ships comes in a capacities of maybe 500 tons, maybe for 50,000 tons or 60,000 tons, right? So on those kind of situations, drums is used. Of course, in the higher grain processing capacity like wheat milling and all, drums are also used as a pre-cleaning equipments. So this is mostly about all the cleaning principle. So moving on, if you see the other kind of impurity which is important for the safety of the equipment itself, and of course the product safety which we are going to get milled from the grains is the impurities which are ferrous impurities. Ferrous impurities being metals, they have to be removed. Otherwise, what is going to happen? It may damage the machine because most of the machinery in the cleaning section or even in the processing grain milling sections are in a motion, right? If any metal comes in, it may damage the equipment. So this becomes very important. In a higher this one situations, even if there is a spark between metal to metals and all, it is what is going to happen. That spark may lead to even to the dust explosion, particularly in the grain silos or the godowns. This one and all. What is going to happen if there is a huge dust accumulated within the silos or godowns and all, and if there is some spark, it has led to a huge dust explosions also, right? So this is very extreme situations I'm talking about. So basically, to remove the ferrous impurities, the media used is magnet, as we all know. And of course, the magnet, if it is used, the separation can happen only when the ferrous material comes in the contact within the range of the magnetic field. So normally, whatever the magnets what we use in the grain processing are of the strength of 2,000 to 3,000 gauss, which is the unit that reads the strength of the magnets, right? So 2 to 3,000 gauss is sufficient enough to remove the regular nails and all, right? Mm, and whatever magnets are used, those are permanent magnets. There is a possibility of using electromagnet also, because by increasing the number of turns of the wires and all, the strength of the magnet can be increased. But only disadvantage is that if the power goes, and during, suppose, even if we have a uninterrupted power supply and all, within that fraction of second also, whatever is been attracted by the magnet can be going on. So that is the biggest disadvantage. So normally most of the grain processing cleaning sections will use the magnets which are permanent magnets. And also, in extreme cases, these magnets, suppose if the magnets are of very high gauge, right, maybe around minimum of 15 to 20 to 30,000 gauge also, the magnets are also used to remove the stones, mostly in the finished products. Okay, particularly I should say the products like semolina, rava and all. There is this one of stones coming in. So if we use these magnets with higher gauge, even the stones, because even the stones and all, they also contain some ferrous material inside it. And these magnets, which are of high gauge and all, they are also named as earth magnet. The name itself is earth magnet. So this is how magnet works. Please remember, these magnets are used only to remove the ferrous impurities, right? Because there are certain non-ferrous metals also, like steel and all. If at all they come in, these magnets are not working for that. So for that, different metal detectors and all which we use, and or of course, if the metal, non-ferrous metal, are bigger in size, they are also going to get out from the size separators also. But of course, if they come in, there is a chance that it may damage the screen also. So most of the time, whatever the non-ferrous metals are there, they are removed also before the size separator also, so that they don't damage the sieve size also, sieve itself. Moving further, relative density or the specific gravity. As we all know, density is mass upon volume. Okay. Normally, standard fluids are water and air, right? So the fluidization. Fluid is nothing but anything which flows and anything which take the shape of the container. Of course, grains are not fluids, right? But while using this principle, we make the grains to fluidize. And the principle the machines which use these principles are called as D-stones and all. Basically, what we target here to remove is material based upon the relative density. Now, relative density of say density of water is 1. Okay, water or air is 1. Now, the relative density, particularly for the grains, will be somewhere around 1.2 gram per cubic centimeter. Okay, and other than that, stones and all, they will have the relative density of somewhere around 2.4 to 2.8 gram per cubic centimeter. So this difference in the grains density is used to take out the impurities, right? So what is the target actually? The target impurities are stones, mud balls, glass pieces, and the metals, particularly the metals which are non-ferrous, right? So these are the impurities which we target to separate out from here. And of course, the media of separation can be either water or air, right? So if you see this particular machine, this is called as a destoner. Destoner, nothing but it removes the stone. And the media used here is air. So what is done here is on the deck, the material comes in. The material comes in, right? And it is connected with the fan, a fan wherein it will suck the air from the bottom, and it comes through the deck. Now this deck is not a normal deck. It will have the perforated wire mesh, which is having roughness. So they stay down and are in touch with the perforated mesh. So and the whole deck is in a vibromotion, right? So what happens? The grain is in the air. The grain is in the air and it is lifted by the air, and because it cannot stay in the air, it starts flowing back because of the inclination and all. It starts flowing back. Okay, and whatever the grain is going down is replaced by the incoming grain, right? So that fluidization state remains always. So this flow indicates that the grain is being fluidized, and continuously this fluidized state is maintained by the incoming grain, right? And what will happen to the other impurities, the denser impurities, being in the down and being in contact with the rough wire mesh, and because of the vibro motion, it moves further, and this roughness will help the stones not to roll down back along with the grains and all, right? So it will stay there, and from the front portion it comes out, and the grain will come from the backward side. So this is how the fluidized state of grain is maintained, and the density, using the density, this one, the other non-grain impurities like stones, glass pieces and all are removed. Yes. Yeah. The next principle or the next machineries which works on this principle is center of mass or shape. Okay. Now, if you see in a grain, the grain, certain grain will have any grain which you are working on, be it rice and all, they will have the oval shape. Okay. Now there are other grains which will come into it and all, that they need to be separated. So normally the principle of center of mass is used here, and what we target is remove the grains which are based upon which are differing in the shape of it. Okay, so it can be done in two methods. Now we can pass it through a indented metal surface or an inclined spiral. You can see these pictures here, these machineries here. The first machinery is a disc separator, second one is indented cylinder, and third one is a spiral separator or turbo one. Now what happens is, let's take the case of the center one, which is a indented cylinder. The cylinder is such that it will have many indents on throughout the surface, right? And this indent is capable, this surface is capable of holding each and every grain, be it grain or suppose the rice, oat, maize, whatever comes in, every individual grain sits into the individual packets pockets. And when it start rotating, the operation is that the cylinder starts rotating. So when it start rotating, the center of mass of that particular grain plays a role here. Now the grain which is having the center of mass outside the indent will fall down. Okay, and the other grains which are sitting very comfortably inside the pocket will travel a further distance. Of course they also start falling down, but they are catch hold by the by the conveyor which is placed at a certain height within the cylinder, right? So those grains are taken out separately through the conveyor, and the grains which are falling down are taken out separately. So this is the way they are separated. Now this is to remove the say remove the bigger grains and all. To remove the smaller grains, we should use a different cylinder. So according to that, the pocket size has to be separated. So in this case, if we are using cylinder, we have to use two cylinders. One to remove the small grains and one to remove the bigger grains than our intended grain. Okay. The same case now, if we are using a disc separator, which is the first figure here, disc separator, the way of the mode of operation is similar, but instead of cylinder, here there are discs again. The advantage of having disc separator is the number of discs which are there. We can always have some discs which are small to attend the small grains, and the half of the machine will have the disc which can attend to the bigger grains and all. So we, in one machine itself, we take care of both the grains and all. But the disadvantage of this one will be the friction is generated because the discs are diving inside the grains, right? So there are high chances that the grains are broken, right? So mostly the gentler way of doing is using the cylinders and all. So that based upon the needs of the grain which you are intended to handle, based upon that you can take a decision on this, right? Of course, now whenever we separate certain impurities, it's not that 100% separation will happen, or it's not that 100% impurities we are going to throw away. Like let's say this example, right, wherein say broken, let's say take the example of wheat. Suppose this machine is placed in the wheat processing unit. What is going to happen is we will get broken wheats also, maybe smaller wheats also, and impurities like mustard and all together coming from the top, right? So these impurities now again we don't want to throw away just like that impurities at all, because we may want to use the broken wheat or the shriveled wheat back into the system, right, based upon the batch what you are going to process. So in this case, what it is done is we can just pass these impurities, the mixture of impurities, from the machine, which is shown in this third figure, a spiral gravity separator. We also call it as a toboggan, right? So here what happens when these materials like say cocal, the mustard, maybe broken wheat and the small wheat, right? When they are put in together, the uh, centrifugal force mv square upon r, you all might be aware, right? So this centrifugal force as well as the smoothness or roughness of the grain will come into play, and this will travel a different path, right? So these three get diverted into three within that toboggan, within that spiral. They move a different path, and at the end of it, you can see the in the picture we get three different outlets, right? So now it is your choice in which way you want to use this grain sample, right? So you get separated mustard, you get separated broken wheat, and you get a separated small wheats also, right? So based on that, now you can maybe just throw away the mustard and all, and you can use this small and this one maybe in the some other blend of the wheat. So this is the way the impurities are handled. To take out based upon the shape, and as I said, the major this one principle is center of mass, which is playing an important role here. Okay. Now earlier days the grains were literally washed. Okay, so what is going to happen is most of the surface was getting cleaned and all. Okay, and it was just done in like machines called as washer weezers. So literally, it is just like your bathtub at all. So what is going to happen? The grain will be coming and moving forward. Okay, now what happens is, see the name itself is behavior during washing, right? So the material falls in, it will have other impurities also like stones, sands, or maybe some husk, lighter materials like husk and all. So what is going to happen here is whatever the heaviest material like stones and all, and as I told you, it is stones density, relative density somewhere around 2.4 to 2.8. So those will be the one which will be falling down first, right? So stones, glass pieces, and all will be falling down first. Okay, and they will have one conveyor which is turning in opposite direction at the bottom, which will take it out. Okay, what will happen to the lighter impurities? This water which is coming in that water bath will be continuous flow. So the overflow, this will be lighter impurities will be on the top. They are not going to sink down. So the overtail, they will be overflowing along with the water. So this is the way lighter impurities are removed. But what will happen to the grains and all? Grains normally the density will be somewhere around 1.2, 1.4 and all. So of course they will also be sinking down, but the pace at which they sink will be slower as compared to the stones and all. So what happens? What is done in these washers, weezers and washers is that there will be a very thin kind of a conveyor is put, which will help the grains to move move forward. Okay. So this is the way this will be taken up. But of course, during this whole process, it will also pick up certain moisture and all. So which we have to take care of. But the drawback of this particular way of cleaning the grains is the amount of water it needs. Right, amount of water it needs is somewhere around 3 to 4 liters per kg, which is huge. This much of water nowadays is not easily available, right? And the other thing is this washed water, when it comes out of it, it is very high in it gets very highly infested with dust, dirt, germs, and all, right. So the BOD and COD of this particular water is gone very high. Okay, so it cannot be just drained out in the normal drainage. It has to be treated. So this adds again to one more unit operation inside your grain processing area, right? So because of these two reasons, this machine is nowadays totally out of the market. But of course, there are very few grain processors still use it and all. But because of the two reasons, one is requirement of water, and other being the water which comes out of it to handle how to handle that because of this higher BOD COD values. This is not been in use for a very from very long time. Okay, as I said, now the cleaning of the surface. What happens? Whatever the dust or insecticide residues or pesticide residues are used during the storage or during the farming, cultivation, and all, it will come on the surface. Okay, so now this has to be removed. This has to be removed, and there are certain grains which are also like infested with insects and infested with this eaten away all the endosperm inside the grain and all. So this has to be removed. So what is done is this is passed through a machine called as a scourer. The machine itself is called a scourer. This scouring will happen. So surface cleaning will happen. So now this machine will have a rotor, and above that there will be one circular screen. So when the material comes in, there will be friction between the rotor and the grain. There will be friction between the screen and the grain, and there will be the friction between among the grains also. So this will lead to removal of the outermost layer, right? And that will come out. That will come out from the perforation of the screen, and the clean grain will move forward. So with this, we have removed dust which are there on the surface, we have removed the pesticidal residues, if any, on the surface, and clean grain is moved forward. And of course, the rotor, what the screen, what we are using, that also will vary based upon your requirement. If you want to remove more of the outermost layer and all, we can go with the emery, like it is done in rice plants. If you want to do a mild, little bit higher this one and all, we can go with the steel wire mesh and all. And normally, otherwise, the perforated metal sheet is used. Normally, perforated metal sheet will remove somewhere around 0.4 to 0.5% of the maximum on a maximum side, the outermost layer. Steel wire can go up to 0.7, 0.6 to 0.7. With emery, you can go up to any extent, right? But of course, the emery requires very high power consumption. So this is based on your need. You have to choose this machine or this particular way of putting the sheets. Friability under impact. This is related with the brittleness of the grain, particularly the hollow grains or the infested grains and all. Again, it is related with the previous principle of surface cleaning, scouring and all. So what happens here? The grains are passed through the whole machine called as impact machine. This machine rotates at a very high speed, and these hollow kernels and all will get hit on the liners again, and they will get damaged. And this whatever damage happens and all will be sucked through the air. So we get rid of all the infested grains and the insect damaged grains with this impact machine. Basically, very rarely used in Indian conditions and all. But of course, basically this machine is used in the floor handling this one, right? But in grains, used rarely. But of course, it can be noted. It should be noted. Now, next principle is air resistance. Air resistance basically works on the terminal velocity. Now, terminal velocity of any grain ranges from maybe around 6 meter per second to around 9 to 10 meter per second. That's right. So, terminal velocity is nothing but the air velocity which is needed to move the grains from the rest. And now, there are impurities which are of the similar size of the grain but are lighter, right? So, these kind of impurities are normally targeted here with the aspiration and all. So, what is done is the whole material is passed through the air currents. Now, these air currents, the fan will be set to certain air velocities, right? So, to take out the lighter impurities. So, they are literally set by the fan based upon the air velocity what we are sending. So, basically, the air velocities of 6 to 9 meter, 4 to 5 meter per second are the operational air velocities, right? So that it will take care that grains will not be sucked off. Yes. Okay. This is electrostatic characteristics. Particularly, you can see here the use, the last, this one what I have written here is it is used to separate the ergot or sand from the floors or semolinas. Okay. So this is very rare thing and all. This will be not used in the commercial, regular commercial operations and all, but maybe if at all the operation is needed for any particular like health related or pharmaceutical related operations, this principle comes into picture. What is done is, you can see here, of course the capacities are very low because to operate this we need the material to go in a single line. Okay, so for particularly in Indian conditions, the capacities at which we operate are very huge, right? So this won't work here. So how it is done is, it the grains or the material is passed through one electrostatic field which has the voltage of somewhere around 20 to 30,000 volts, right? So when the grain comes here, this they get charged. They get charged, okay, positive or negative. Mostly the good grains will get certain charge, and other impurities will get a different charge. Of course, when they come out of it, we put two electrodes, a positive and a negative electrode, and also based upon that it get segregated. But bear this in mind, this is not very feasible commercially because of the very lower capacities and all. But of course, if certain candidates are working in some pharmaceutical companies and all, this is the way it can be done. Of course, color difference now. This color, this one machine was particularly designed earlier for the rice processing units, because rice is sold as a grain and mostly the rice kernels are white in color. So even if one particular speck of black or any other color comes, so it impacts the whole marketing of the rice. And also, and one more thing is, rice processing or rice cleaning machine mills which are there in India operate at a maybe even 2 tons, 1 ton per hour also. So those color sorters, the equipment which uses this principle is a color sorter. So they were designed to handle those capacities. The grains like wheat and all are processed at a very huge scale, like 200 tons per day, and going further up to 1,000 tons, 2,000 tons per day also. So those equipment, those color sorters were not designed to handle that higher capacities also, and it was not needed also. As I said, because of the way rice is marketed, this one as the whole kernel, which is in white, it was much more feasible and much more of use in the rice milling industry. So of course, what is done, and the same color sorter can be used for any grain. Only thing is you have to select the color which is your asset. So in like particularly in rice, it is a white color. Okay, so any color which is lighter or darker than rice color is your impurity, right? So now this is how it is handled. Is the grain will pass through a chute, and there are two cameras which are put. One camera is light camera and one camera is a dark camera. Means they will detect the impurities which are lighter, and one camera will detect the impurities which are darker in color. Okay. So when the material comes in, as seen in the picture, they detect this. They take the pictures continuously. This camera they take the picture continuously, and they have a very high resolution. These cameras very huge resolution, 10,000 to 15,000 megapixels and all megapixels also. They take pictures, and whatever the information is there, it is passed to the signal processor, which in turn is connected with the ejector. So if the camera senses that there is something which is coming lighter or darker, this signal processor will give command to the ejector, which is again connected with the compressed air, and it will just blast the air there, compressed air, and we get the rejects separated from the regular accept, which is our rice and all. But of course, it is not so that no rice will come. So of course, some of the rice or whatever grain you are handling will also come along with the rejects and all. So to handle that, there is one more chute which is called as a recycling chute. So again, that operation is repeated here to as well to retain whatever the grain we have lost with the ejection along with the impurity. So this is the way all the cleaning machineries are designed in any grain processing industry. These are the basic 10 principles on which any of your cleaning machinery is designed, and this is the way you have to take use of the let's say in the terms of sieve, right, based upon your size of the grain which what you are processing and all. You have to select the particular size of the sieve to separate out based upon the friction what we need for the removal of the outer layer of the grain bran or whatever this one. You have to select the machineries based upon what is your grain processing mills you are working on. So this is all about cleaning. Priya ma'am, we are going to take the questions at the end or in between also we can take it. Okay, fine. Moving further, grinding machineries. Okay, so this takes us to the further part of processing, which is grinding. Okay, basically these are the three grinding equipment or pulverizing equipment we use. Okay, so I'll just brief it out because I'm not sure which industry you people are here. So the first and common way of processing the grains is we know all stone chakki, right? Wheat chakki. Now, basically, this stone chakis comes in commercial stone chakis will come in a dimensions of somewhere around 24, 30, 36 inches and all. Okay, so they have capacities of somewhere around 200 to 250 kgs per hour, or almost 400 kgs per hour, based upon the size what you are using it. Now, of course, these stones are not just normal stones and all. These will have the furrows also. Okay, so the furrows will come in three different types. One is the main furrows, which will help in transporting the material because the material will fall in the center, and this is used for basically wheat, but jawar, bajra, all the grains can be ground using the hammer mills, right? I'm sorry, the stone mills. Now, what happens is when the fall in the center, the material is transported through the main furrows. This is the role of the main furrows. Side furrows will turn the grain, and actual grinding happens at the periphery only. If you can see the blue lines, this is where actual grinding happens. Okay. Now, among the two stones, one stone will be always stationary, and other stone will be rotating. Mostly the top stone will be rotating, and even the gap adjustment of the between the stones is done by the from the upper stone. In general, right? Most of the stones chakkis will be having the top stone which is movable, right? So the stone gap will help in choosing what fineness you want. So of course, if the roll gap is less, you will get the finer floor, whatever grain you are grinding there, and vice versa. One thing should be noted here is because of the material time, the time material spends, because you can see it falls in the center and travels a distance of as equal to the radius, and also the time spent by the grain is much higher here. So because of this, huge heat is generated. You can see whenever you are going to the state wheat chakki, atta mill and all, you can see the floor coming out of it. The atta coming out very warm. Okay, the temperature is somewhere around 78 to maybe even 73 to even 80 degrees Celsius also. So this heat, because of this heat, you cannot just what you call pack the floor, whatever is produced there, right? Otherwise, the lumps will form and condensation will form and lumps will happen there, right? So it has to be cooled before you pack it. So and one more advantage of the stone checkers is we get a very good starch damage. The starch damage comes here. Again, it is related with the grinding forces which are acting and the higher pressure which is coming because of the more time it is in this one. And all the damage starch what we get here in the chakki atta is somewhere around 16 to 18%. So that is the reason it will absorb more moisture, and your chapatis will stay softer for a longer period of time. So this is the overall thing of stone chakki. But one disadvantage of stone chakki is one is the smaller capacities. It runs hardly some 250 to 400 kgs per hour, as I said. So for very huge capacities, this is a limitation. And the other drawback or limitation I should say is the grinding area is only at the periphery, and suppose the mill is running continuously, just within 1 week or 10 days that this one will go. So we have to again chip the stone, and this chipping of stone needs a skilled personnel there, right? So every 10 days and all, you should chip the stone at the periphery. So it needs some spares also. The stone checking spares are always should be there in your plant, right? So this is about stone checking. Now hammer mills, you see now hammer mills again, they are used basically for any pulverizing action, any grains also, and also in the cleaning sections. In the cleaning sections, when you have impurities, right? When the impurities are come, like the impurities like the straws, sticks, and all, right? So they can be ground in this and mixed along with the bran, because mostly the bran goes to the animal feed, and animals digestive system is well designed to even digest the, of course, the grass material and all, right? So they can digest it. So mostly for the time of price relation, for the impurities, mostly the stick straws are ground in hammer mill to the size of the fine bran and mixed with it, maybe in the percentage of 3 to 4 percentage with as of the bran, right? So the working principle, of course, is the impact. There are hammers set in the rows of 6 to 8 in the whole rotor, right? And there is a screen, so it runs at very high speed, somewhere around 2,500 to 3,000 RPM. Okay, what happens? Whatever comes in, it is just impacted till the time it passes through the screen size, sieve size what we have used. Anything which comes there will be ground, will be this one, right? So basically the this one importance is the dynamic balancing of the whole rotor, right? Because in one row there will be somewhere around 4 to 8 hammers. So if we are working in the in say clockwise direction, right? If you are continuously using a clockwise direction for that rotor motion, what is going to happen? The side of that particular blades will get wear and tear, right? So what is going to happen in the longer run? This wear and tear will lead to the imbalance of the whole rotor, which will directly affect the motor, because most of the time it is directly coupled equipment. Motor is directly coupled to the rotor, right? So it may damage your motor also. So it is always wise, one thing, for the longer life of the hammer mill, to run the hammer mill one side on day one, right? You can just turn the hammer mill in the opposite direction. It can be just done by the wires, electrical wires, RYB. You can just change the connections, right? And it can made it to run in one side on day one, and in the anti-clockwise on the day two, and all, and follow that this one, okay, sequence. One thing is here, if anything comes here, like particularly like metals and come metal nails and all, if it comes, what is going to happen? It is going to damage your screen. Okay, so it is always advisable to have a good strength or good capacity magnet above the hammer mills. Otherwise, your machine, because rotors, screen, everything is going to get damaged with this. Okay, so this is very critical point. And also because it runs at a very high speed, the vibrations which it may produce are going to go to the floor and all. So it should have proper shock absorbers like rubber absorbers and all should be placed for this. Okay. So roller mills, basically this is used in it was designed to process wheat kernels. Okay, wheat kernels basically in the for production of maida. What is done is, we know the wheat kernel has bran out 14% outermost layer, endosperm is 83%, and the germ portion which is around 2 to 3% and all, right. So basically, roller floor mills are were designed to remove the bran and germ. And whatever endosperm is there, it should be milled into maida basically, and semolina. Okay, so this process, the whole rolling process, is a very gradual process, unlike hammer mills and chutney mill, wherein we put the grains and we will get the product out of it, right? So here, this is a very gradual process, very slow process, and involves a machines called as roller mills, which will have the shield cast iron rolls, which are shown in the picture. You see, there are two types. One is having the grooves, which are called as brake rolls, and one are smooth, which are called as reduction rolls. So basically, this whole operation after cleaning, water is added, right? And these brake rolls, we call it first, second, third, fourth brake. What they do is they cut open the grain, right, and slowly scrape the endosperm, keeping the bran intact. So whatever endosperm has come in, right, and the bran has gone out. Okay, so this endosperm which is there is ground into powder with the help of the reduction rolls, which are smooth roll or polished rolls, right? So flour or maida is nothing but anything which is having size less than 150 micron. Okay, so the difference between maida and semolina is nothing but the size difference, right? Size difference is what segregates them from each other, but otherwise there is no bran and no germ in both of them. So with roller floor milling process, what advantage we get is we get multiple products in one process itself. Basically, we get maida, which is somewhere around 60 to 70% of wheat what has gone in. Rava somewhere around again 6 to 7%. We get resultant atta also and bran of course. So in one process itself, we get different this one, right? And the process, as I said, is a very gradual process, and we can make any kind of flour or maida to suit the different customers like bakery. In the bakery also bread, cake, parota and all, just by selecting the right blend of wheat. Okay, but nowadays this whole technology is also being used for the millets. Okay, particularly for the production of semolina and all. CFTR has developed many technologies based upon this process, right, to make the semolina out of millets and all. It has worked quite good, and products are also in the market. Yes. So this is what all from my side. So any questions? How you're asking? Maybe Priya ma'am can intervene here. Ma'am, question answers का कैसा है? Any interaction and all? Yes. So I have finished with this one and all. So they may be allowed to ask my questions if any. Right.
Participants, if you have any question, sir, or write in the chat box. Sir is here to clarify your doubts. Participants, you can unmute yourself and you can ask the question to sir directly. Sir, some participants asking for the PPT also.
PPT, of course, ma'am. Okay, I will email to you. Further,
Yes,
you can share it with them.
Ma'am, sir, one question is there. Selection guidelines for selecting mills by small scale entrepreneurs.
Okay, I mean, what I understand the question is now, see, the capacities of any mill, any grain you are going to process basically depends upon your market first, okay? And the machineries, normally machineries, any machineries, say rice mills or wheat mills and all, they come at a varied capacity, right? As small as 10 tons per day plant also can be put, okay, and to the, as I told already during my presentation, also you can go up to 1,000 tons per day also, right? So it is your market, it is your investment, this one, and the region also plays a important role, where you are and to whom you are competing, what is your target customer, right? So these are basically the inputs which has to be considered before selecting your capacity. And suppose you have plan of putting up a plant, a grain processing plant of say 10 tons, just being a very small scale, this one, right? You should always keep in mind the expansion also, because there are high possibilities that your market is going to expand, right? So you cannot keep on multiplying the your plants and all, right? So there's always scope should be there within the existing system, that you have to invest very little for the further expansion, right? So I can just give one way of handling it is like, suppose there is a cleaning section and there is a grinding section, as I told you, right? Cleaning sections normally machinery can be put in a higher capacity, right? Suppose you have plan of 10 tons per day of the grinding capacity. Okay. No, okay. I'll take it some 100 tons per day grinding capacity. Okay. and your cleaning machineries will have the capacities to finish all the cleaning in say only 8 to 10 hours, right? So that you get the clean grain for grinding for throughout the day, right? And suppose expansion happens, right? So you need not, and you just run the cleaning section for 8 10 hours and stop it. Now, for going further, right? So after year, 2 years, 3 years, and all, your capacity of grinding is increased, right? So you need not to again invest on the cleaning sections and all. You can always go for just increasing the grinding capacities. In grinding also, you should also already have certain provision that the additional equipments are going to be integrated in the same flow sheet. And coming back again, the cleaning sections, when your capacities are higher, are good enough, right? So you're finishing your cleaning in 8 to 10 hours. This other time, what is left, you can always use this cleaning section for third party operations and all. Maybe you can take the grains from like big brokers or farmers just to get clean and give it to them, right? Many supermarkets also, what they do is they just clean the grain and pack it. So maybe these kind of operations can be additionally put in the same existing system.
Thank you, sir. Uh, Participants, if you have any question, you can write in the chat box or you can unmute yourself. So, one more question. What are the additional equipments that need to be included in startups involving milling industry?
What are the? Can you please repeat, ma'am?
What are the additional that need to be startups involving milling industry?
Involving?
Involving milling industries.
Okay. You see, milling industry, as I said, any grain, right? Be it millet, be it wheat, be it rice, is a milling equipment, right? So startup, that is what I just explained here and all. It depends upon what is your target market and all. Milling in roller milling, as I suppose. Let's take example of wheat milling. So what all the equipments will come in? The basic grinding equipment is the roller mill, which is you can see here in the picture. You can see here, right? In the slide, what is this one? So now these are the multiple equipments only will come. Basic equipment is the roller mill. So roller mill will with the brake system and roller mill with the reduction system. So these are the only grinding equipments in the roller mill. When you are doing processing of wheat for maida, right? Same way when you are having wheat for atta, right? That time your equipment milling equipment is checking, right? So the grinding equipments are only one, but the number of it multiplies when your capacities increase or decrease, right? So this is what it is. Of course, in the other, as I told you, in the cleaning section, you can also have hammer mills and all. It depends upon what particular reason you want it, and also your like rice mill is there. So the actual processing happens in the with the rice polishers, right? So rice polishers will come with the emery. Quality. I was referring to the
So she's saying that she was referring to quality facility.
quality. Of course, quality means if I understand your question, quality means suppose is the quality control, right? See, it's not that quality analysis. Okay, yes, okay, yeah. So now you see for any grain processing, this one, the consistency of the final product is very important, right? So consistency will happen only. Consistency can be evaluated if there is a quality control lab in your facility, right? So basically, this floor, I'll take again example of wheat floor mill, right? So what are the equipment needed? If you are asking that, I can tell you one thing. The basic is the moisture, okay? Grain moisture. For that, oven will come, INR moistures will come, okay? Now, the second important aspect of the floor is the protein content. Okay, so the protein content, the basic or lengthy process is the microgeldal method and all, which is normally not done. For a day-to-day basis, we do the sedimentation values and all. Okay, the gluten content and all. So these are the equipments which need to be done. So basically, if you want me to segregate, classify the equipments which are basically needed. Okay, for a standard good lab, one thing is moisture content. Second thing is protein content. Third thing is ash analysis. Okay, which needs over, and the ultimate product quality evaluation is done by the product making. Okay, whatever your floor says, so there should always be a person who can make the product which you are going to supply, right? So there should be a baker which can bake your bread with the flour which is coming. There should be a porota master, which if your plant is in say southern side like Tamil Nadu, this one and all, so you should have porota master there. So these are the basic equipment or the facilities which are needed to keep track of the quality of your milk products.
Thank you, sir. Participants, if you have any question regarding the things, you can ask. Lakshmi, can you unmute yourself and ask directly to sir?
Yeah, I got her point. You see now, if the flour mill is there in southern states, okay, southern states generally don't grow wheat, right? So for this particular thing, that any flour mill, if you're talking about a wheat milling capacity, it should always have the capacity of 30 days minimum. Of course, it is not a thumb rule. So 30 to 40 days storage capacity must be there because the wheat comes from the northern side and it needs transportation time and all, right? So it should always be 30 to 40 days, if I got your question.